All right, welcome to the Explainer. Today, we're going to jump into Merg. It's a domain-specific language for Web3 that has a really unique take on security. You know, its whole philosophy is about making the safe way to do things the easy way to do things.
And this quote, it just nails the entire philosophy. The core idea is actually pretty simple. The safest, most secure code shouldn't be the hardest to write. It should be the easiest. It should take the least amount of effort. And that one single principle, well, it shapes everything about how Merg E handles sensitive data. It's a fascinating way to think about security.
So here's what we're going to cover. We'll kick things off with that core philosophy. Then we'll get into a problem that every single developer faces, managing secrets. From there, we'll unpack all the layers of security Merg E uses to solve that problem, from its basic syntax all the way up to a dedicated vault system.
Okay, so Merg E is what you'd call a highly opinionated language. It's designed specifically for the InnuenDo Web3 stack, and its biggest opinion is this. Security should never, ever be an afterthought. It should be the default, the path of least resistance, literally baked right into the language from square one.
Now, let's talk about something every developer has dealt with, right? I'm talking about API keys, private keys, passwords, all that secret stuff. What do you do with it? How do you manage it without, accidentally leaking it to the entire internet?
The easy answer, the convenient one, is to just stick them right in the code, or maybe in a config file. But that convenience is incredibly risky. All it takes is one accidental git push to a public repository, and boom, those secrets are out there for everyone to see.
If you see a line of code like this, alarm bells should be going off in your head. That is a secret just sitting out in the open. Now, in most other languages, it's totally up to you, the developer or maybe some external tool, to catch this mistake. But in Merg E, the language itself is designed to step in and say, whoa, hold on a second.
So the language itself actively nudges you away from this really dangerous habit. The compiler sees a big long string and basically says, hey, this looks a lot like a secret. Are you absolutely sure you want to do this? You should probably be using a vault for this kind of thing.
And this is the first crucial point. Merg E's first line of defense isn't some extra tool you have to run. Nope. It's built directly into the syntax and the type system of the language itself. It all works on this principle of being sensitive by default.
So how does Merg E figure out what's potentially a secret? It's actually super simple. It's all about size. It just looks at the data type's capacity to hold a secret. So over on the left, you see small types, like a Boolean or a single byte. They're considered inert. They just don't have enough room to hold a typical API key. But the larger types on the right, like a string or a big 256-bit integer, well, Merg E just assumes those are sensitive by default.
Okay, so what does this actually mean when you're coding? Well, this is the practical consequence. Take a look on the left. That inert data, the small, safe stuff, it just flows freely. It gets automatically captured and used inside other functions, what we call closures. But check out the right side. That sensitive data, it stops at the boundary. You have to be intentional about it and explicitly tell the code to capture it, which makes you stop and think about where your potential secrets are actually going.
Now, of course, you might be thinking, hey, what if I have a really long string that I know isn't a secret? Well, the system can have false positives, and for those cases, Merg E gives you an escape hatch. You can explicitly mark a variable as inert, just like you see here. It's basically you telling the compiler, hey, I've checked this myself, it's safe, let it through.
So let's move on to the next layer, because this is where it all starts building into a really robust solution. If you're not supposed to hard-code your secrets, where do they go? Well, in this ecosystem, they go into the InnuenDo VaultFS.
Okay, now this is absolutely critical to understand. It is so important to know what VaultFS is and what it isn't. It is not a cryptography library. I'll say it again, it does not do encryption. Its whole job is access control. It's like a bouncer for your secrets, making sure that even if two programs are running as the exact same user, one program cannot get access to the other program's secrets.
And the workflow here is super simple but really effective. So first, an admin uses a special write-only tool to stick a secret in the vault that's tied to a specific application. Then, when your app is running, it asks for that secret. Step 3, this is the magic. VaultFS checks your app's unique identity, things like its exact file path and user ID. If it all checks out, you get read-only access. And step 4, any other program that tries to read that secret, even if it's running as you, gets absolutely nothing. All right, this brings us to what is probably the most powerful security idea in the whole Merg E ecosystem. And that is the ability for the Merg E runtime to use secrets
that your own application code can't even see or touch. And the way it pulls this off is through a really simple but just brilliant convention inside VaultFS. The vault for any application is split into two separate little areas, one called code and one called runtime.
And here is where it all clicks. Your application code gets to access secrets in that code namespace. So for example, reading an API key to make a web request. Perfect. But something like a private signing key can be put in the runtime namespace. And as you can see, only the Merg E runtime itself can touch that. Your code can't read the key. Instead, you just call a built-in function like ambient.signer. The runtime goes and gets the key, does the signature for you, and just hands you back the result. The key itself was never ever exposed to your application. How cool is that?
So all of this sounds amazing for production code, right? But what if you're just messing around, just prototyping something? Setting up a whole vault can be a bit of a pain when you just want to test an idea quickly. Well, Merg E gets that, and it provides a practical but very, very explicit escape hatch.
And this workflow is designed to let you move fast, but also keep you honest. So first, you can use the hazardous modifier to just temporarily hardcode a secret. But then, as you see in step 2, the compiler will just fail by default. It won't let you. To get around that during development, you use the wonderfully named -trustmebro compiler flag to override it. It's a clear signal to everyone, including yourself, that this is temporary. It's a fix this later flag, before you finally refactor it in step 4 and use the secure vault for production. And the final takeaway here could not be clearer. These tools, Hazardous and -trustmebro, they're for development. They're for prototyping. The right way, the idiomatic way to write production Merg E code is to use the secure, vaulted approach. It's not just a friendly suggestion, it's a core part of the language's design.
So when you look at it all together, the syntax, the type system, the VaultFS, Merg E's multi-layered approach offers a really powerful alternative. By making security the path of least resistance, it fundamentally changes how you as a developer have to interact with secrets. And it leaves us with a really fascinating design that challenges all of us to answer this question. If your language made security the default, how would your code change?